Hello and welcome back to module number 4. And today we're going to talk about R programming structure. We're going to cover a lot of pieces in order for you to have better structure of R with regard to its programming language. We're going to talk about missing values. What do we do with that? And then we're going to talk about functions and arguments, loops, and in the end, I'm also going to talk about Boolean operator. And usually a Boolean operator is known in information science with regard to information retrieval, and we will try to see that in R. So let's start with missing values. Missing values is one of the most common things that we often encounter when the data is missing values. And in R, it usually generates the letter case by NA, which is the missing values. And in this case, example, a container contains three values, 5, missing value, and 12. And when we ask the R to calculate the mean for that, he will say, I'm sorry, I cannot do that because there is a missing value, a missing piece in my calculation. So we can test this as a condition which is called is.na, and we apply to it and say, what does it really mean? And we apply it as a vector for missing values. And in return, the R will come and say true, false, true, false, in order for us to see what does it mean. So in this case, the returns of true is X is missing. And so if you have a large data set, this is quite useful, and especially when this data set it consists of missing pieces. So again, this is one way to overcome the idea of missing values, something that other applications such as Excel or SPSS do not address. Another thing that we can do is with regard to the mean, and again, we have a container Z and we have a missing pieces, missing values, and we can say the RM equal T. So in this case, the missing value from the analysis is that we are asking that the option of RM as a true value in order for us to overcome the missing value. So NA.RM stands for return a vector, which means true or false. NA.fail is to stop any missing value that are encountered. And again, this is options that the R provides you to overcome the issue of missing values. And one of my favorite is NA.pass is no action is needed if you are comfortable with the result. So I'm going back to functions. And functions, and again, as we said beforehand in module number 3 and 2, is the foundation of building blocks in R. So you already created many functions or encountering many functions. And so let's start with the basic. F1, and we call it a function with x and y, and we will say x plus y, and we will close it. If we will give it a value, 3 and 4, the function that we called f1 will be able to add those two the values into 1. So most have arguments that giving more information about exactly what they tend to do. So if you would print hello world, it will give the arguments that x is the printing values. So as a result, the argument is a function called x. So in this case, the print and I'm giving 4 values, and I'm saying that x is equal 11 divided by 7, and so the result of it will be the value of 1.571. And again, the print is a function that I be able to allow me to display it and be able to use it in order for me to create my own functions for the finding of the objective of my research. So the issue in R And this is really important because when you pass a value that becomes an argument, for example, SQRT, which is a routine that returns the square root of a value. So then this function, and if I will have it in container of 25, it will return the value of 5. The value of 25 then is becoming the argument. So the syntax in R in this case is the function, you have the argument, and do something interesting in order for the function to return. So the functions in R are first class object, which means they are treated much like any other R object. So they pass an argument to other functions, and the function can also be nested, so there can be defined a function inside another function. So if you have a name argument, a values, so R can hold the function, hold the arguments in the function. Example, my data, and I will say random numbers of 100, and I will say standard deviation, and I will say my data, and I will ask the data to be applied to the arguments that I'm trying to make in order for it to do that. Even though it's legal, I do not recommend to mess around with the order of the arguments too much, since it can lead to some confusion inside of the R. But it is optional, and I saw a lot of arguments that made in the function in order for it to lead. So in this example, again, I lay out for you calling for a function, how to make the function more operative, and then match first exact name, then the prefix match in order for you to do that, and you have the foundation of the arguments and how it lay out. You can also mix positional matching by matching by name, and this is interesting. Why? Because when an argument is matched by a name, it is taken out of the argument list, and the remaining unnamed arguments are matched to others that are listed in the function definition. So, example, I'm calling for a function called args, and I'm going to say lm. So the function has some properties that I need to define. The function, the formula, the data, the subset, the width, the action, the method, the model, the value of x or the value of y, the QR, and everything that goes with that. So the args is a function stand for calculating the mean. So the matching argument, that is that it enables us to check the exact match of a name argument, able to check the match with regard to the position and regard to the who is participating in this match. An example, f is a function called a and b, where b is equal to and c is equal to 2, and d is a null. And so this is a function, this is a working function that has some arguments inside of it. When we are talking about, which brings me to the next subject, which is the null. And in addition to specifying a default value, you can put into the argument that the value is null. So it is a part of your arguments that you're going to make. And so in this case, I gave a layout exactly a little bit more about what is the value of this argument. So this function never actually used the argument b, so it's calling for f2 will not be produce an error because 2 gets the position that match to a. So in this case, this is what it ends up. I'm not using the b, but I'm using the a, and in this case, it will not cause a problem because how I lay out my arguments. And also the issue of syntax. One of the things that R is quite good at is the ability of the syntax. In this case, we'll talk about the three dots that can come into the arguments. So the three dots indicate a variable number of arguments that usually pass to other functions. So usually you are going to have the idea of the arguments that able us to apply to it and give some ideas what it ends up. Generic function use is the idea that already exists in R. We have a lot of functions. So in this case, we can use the three dots as a generic function in order for us to do that. Example, mean function x and then three dots, use method mean. So the idea here is that three dots will be the arguments that is also necessary for the number of arguments passing the function that cannot be known in advance. So the idea here is that we are using it in order for us to add and apply to something that we cannot know in advance in order for us to calculate that. So again, how I lay out on that functions and how I make my argument on it is part of the issue. But the same time, we need also to talk about loop. And what is a loop? Is a sequence of instruction that usually continue repeating until a certain condition is reached. And I'm sure that some of you already had taken any programming language and that consists of a loop. The same goes to the R. If you never had a programming classes, a loop is something that we often use to have a structure to search or conduct some action out of it. So it is something that is very common, and one of the things that is most common in R to use the loop for and while and apply loop. Less common are the repeat loops and the break function that is also used to break the loop and the next half of the process of the current advance of the looping index. And I will try to give you an example of it. So for the loop, the repeat a line or lines of the code until the loop counts the limit is reached. For example, for I and in 1 and 10, and I will say the code, and I will ask the R to run it loops 10 times. So we have a loop here, and in closed loop, we are going to do the end in order to do that. So the variable I updated the loop to value in the sequence of 1 to 10. In the following example, I will use the p-value. What is a p-value? In statistics, the p-value is a function of observed sample result that is used in testing statistical hypotheses. So when you're using hypothesis is usually known for p-value. So where is the p-value in this case? So I will lay out that the p-value in this case is a container that has some value 0, 1, 0, 0, 5, and so on. So the vector that stores the negative log of p-value is equal 1 to 5. So the transformation of the p-value in this case, 4, again the loop stands for the 4, and the p in 1, the length of p-value, and we're going to go through minus log 10. So the idea here is that it will go through a loop until he be able to find the values that we are searching. The repeat lines or lines known as a block of the code until the code is being reached. For example, while, stop, and when it's true. And again, this is the structure of the while loop and how it apply. So the above loop runs until the code said and stop when it's true. But it is, I like to say a warning here that if the property written while the loop is run, it can run unstartable. Wow. So a simple while loop in this case, and again, this is how I will do it, and this is how I will print it out, and I will say paste v1 and apply it to the set that I have already. So background on the functions that I'm using in the loop. So bytes of the codes that do one thing and do it well, the function breaks into your code and allowed us to use as a way for us to use the loop and be able to construct the function in order for us to do that. Example, fun, I will call it a function arguments, and I will call it the code. The calling is, again, I can apply party and I will call it as my function, and fun consists of food, beer, and folks. And by doing that, I broke down the function on it. So in this case, how will I apply in the loop, and how would the loop go into it? The issue is that the while loop be able to repeat the same syntax or the same function and again until he will be able to find it. So in this case, I'm going to use numeric values and I'm going to run it until I will have a value that is smaller than n. And by doing that, the function that is consists of n is broken down and be able to help me to structure my arguments. Another example, student t-test. Usually t-test is ability to compare control group versus treatment group. In back to statistics, usually we have two groups. We like to measure what is the control and what is the treatment, and how those two groups interact, or what is the intervention between them. So we are comparing the means of two groups. So in R, we are allowed to do the comparison with specific drugs on students' sleeping habits, and by using the t-test, I will be able to apply the loop as when I will lay out that the extra group will be able to apply to it in order for it to do that. And the t-test in this case, it will allow to do the loop until the data is equal sleep. So in this case, the result of the t-test in this example is that the mean of group 1 compared to the group 2 mean is that group 1 is 0.75, group 2 is 2.33. So this is a big difference, but again, this is how we apply that. And if we will apply the statistics or the hypothesis into it, we will say that we are 95% confidence interval, and this is the result out of it. So here are the functions that can be implemented looping to make your life easier, which means that if you are going to break the function that you wrote, or break a function that already exists in R, implementing the following function will help you to sort it out to make your life easy. Apply is a loop over a list and evaluate the function on each element. Apply, same as apply, but help to simplify the result. Apply is the function covers a margin of array. T-apply applies to the function of a subset of a vector. M-apply is multivariant version of apply. And again, we can slip the function also. So let's look at L-apply, the first loop. So the take the apply take three arguments. First of all, a list of x, the function or the name of the function, and other arguments via its arguments that it consists. So if x is not a list, it will encounter to a list using the function called as.list. So lapply function s and fun, and I'm going to leave 3 points out in order for you to make an argument. And so in this case, the arguments that I'm going to have is that function will be match.fun, and in this case the quotation, and I'm going to have it if condition. If condition is again part of our arguments that we will try to do, and I will talk about if condition later on, but this is part of how we make an argument that is often used in order for us to make sense or to sort data out and help us to understand its essence. So in this case, I'm making an argument of if, and if x is as list x, the internal I will apply to lapply in order for it to find it. So the actual coding loop is done internally in C code. So the fun is it attempt to match as a function. So it is also part of the lapply always return with the list regarding the class of the input. In this case, again, I lay out a list. I lay out what is the A, what is B, and I gave specific values to it, and I asked to calculate the mean and how we apply it in order for it to find. The next is apply, and apply is again to evaluate a function, and it usually often used to apply a function to a row or columns of the matrix, as we talked about the matrix in last module compared to the data frame. So it can be used with general array, taking the average of the array of the matrix. It is not really faster than writing a loop, but it also works in one line. So again, I will apply the x as a matrix with a normal distribution of 200 with a 20 and 10. So in this case, we use the x and apply matrix, a collection of data, into two-dimensional. And we also use a normal distribution just to make sure that we are synchronized with the distribution of this data. So apply x to mean, and it will come up with the following values. The next loop functions, and this in this case, again, if I will change the last arguments, in this case I will ask for the sum, it will do the same thing for us. We also have a shortcut. A shortcut is the sum and the means of the matrix dimension. So we have some shortcut that can apply that. Row sum is the apply x1 and sum. Row means, again, just a shortcut in order for us to make our code more concise and more applicable if we are going to write a large set of lines in order for us to do the calculation. Again, the next one is tapply is the next function, and again I want you to go I lay out for you in the PowerPoint presentation every step on the way how to apply that, how it means, and try to see if it makes sense. If it not, I will fix it or I'll give you another example as does the book. And again, this is the example of it and how to do that. Again, we can also talk about split function, and a split takes a vector or an other object and split it into groups determined by the factor or the list of the factors. And again, this is a function that it's quite important when we are talking about not a large set of data, but a group that can be divided into subgroups, and that function is really helpful. So example of it and how to apply to it and what does it really mean. Next, I need to talk about how to apply operation or mathematical operation and values in R, and how to apply that into your values and operation. So we have x plus y is addition, minus is subtraction, and all those values are part of a syntax of how to add or divide or to modify values in that sense. Next is the logic. And the logic is the idea of valid of reasoning. And it is the ability to establish criteria to whether some piece of reasoning is valid or not valid. So when we use by valid reason, we are talking about is it true or false? And by using it, we can say who killed Mr. X, and by using it, we can apply logic structure of the sentence in order for us to find is it true or false. So the valid reasoning has some rules that we can apply into R. So example, if I win the lottery, then I will be happy. However, if I will not win the lottery, therefore I will not be happy. So this is the idea of validate my arguments that I'm trying to do, and we have two conditions, valid or invalid, in order for us to do that. Sound reasoning, it's not all about valid reasoning, is not about good reasoning. It's an example how to make it all work out with the structure of this, how it sounds to us. So the idea of true and implementation is part of how we apply it to R and how we assume its nature. And by doing that, we are able to, again, use the logic to make an argument and to have a conclusion that makes an idea of what is the premises and how the conclusion match up to it in with regard to logic. So we will apply to it, and logic is often used in computer programming. In R, the use of logic is for control structure. So we have comparison operators that is part of how we structure the arguments. We have logical operators that where we lay out the and or not. And again, the zero is considered false and non-zero considered to be true. And this is how we often apply to it in order for us to do that. So the operators, how we apply to it and what is it, the description of it. And for example, the X, and we have a container, true or false, 0 and 6. And with the Y, everything is laid out in a logic, false, true, false, true. And we ask to calculate the X and how to multiply the X multiplied by Y in order for us to do that. So if a statement operates on the length of logical operator, we have a structure, which is the if condition. So if condition 1 is true, then we apply else. And by doing that, we can lay out the foundation of the arguments. So if 1 is equal 0, we can print the result, and else we're going to print the result. And by doing that, we're able to see what it is. So basically, this was introduction to the idea of if-else statement. And this is known in any programming language, but also in English. If I will win, or if I will get an A in this class, I will be able to get a job. Okay, so this is the if-else statement in implying it into computer syntax, and by doing that we can apply some conditions and some values into it in order for you to do that. So example, a simple example of if-else statement, again in this syntax, and how to run it with a real value 1 to 10, and what it will give me if I will specify what is the value of x, what is x smaller than, and what else value I want to see, and in order for me to get it. The last subject that I want to talk about is logic with regard to structure, or the idea of calculus of logic. And in this case is chocolate and nuts and mint, and if we combine them together, we'll be able to get the best flavored dessert that can be made up of ice cream. So this is the idea of logic, and the idea again, cheese, sausage, and pepperoni together on a pizza is the best pizza ever. So the idea here is that a quick review before diving into the true tables. It's about the idea of what does it the syntax of it consist of, and what is the formal, not what does it stand for, and, or, if, then, if, and only if. And by doing that, we can apply Boolean logic into the idea of what it stands. So the rule of logic are now multiply inputs and output produce outputs. So we can define the rules by using true or false. So the idea here is that by doing that, we can apply true or false and calculate P versus the Q in order for us to do that. P or Q, and if we will do that, we will come up with true, true, and false, false. And again, this is part of our arguments that we often use in research or in information retrieval in order for us to retrieve things or to apply things. So I lay out for you the Boolean logic and how it consists of, and the idea of using Boolean logic in order for us to find the true or false value of those calculations. So again, this is part of the arguments that we will see how to apply, and you will have it in your PowerPoint presentation. But how, again, back to R, and how do we apply that into a calculation, and what does it means and how to apply that? So a general outline for Boolean values in R is that, first of all, the values has to be true or false. They can be abbreviated to true or false, but they must be capitalized. And we can invent your own operators, as our textbook stated for us, is that the function whose begins with and ends with percentage can add to it. So this is that's it for this presentation. You will have more information about what we have done and how we going to pursue this. I know I cover quite a lot. I not cover every subject very in depth, but I would like to say that the structure of the assignment will give you better understanding what we did. Last note I want to make with regard to GitHub. And the idea of GitHub is that if you did not download the application to your computer, you will not be able to do the synchronization to your actual work. So even though you have an account with GitHub, it doesn't mean that your code that you write on your desktop or any other file will be synchronized to your online. In order to do the synchronization, you need to download the application or the software that goes with the GitHub. So that's it for now. I hope you enjoy it. Until next time, have fun.